Okay, let's get some terminology out of the way first. Some fundamental concepts. Now, the term the statistics is used to refer to data and to the methods we use to analyze the data. So, when you say let's collect some statistics on a particular company, you're really referring to the data. And as for the methods, we have two statistical methods, descriptive and inferential. Descriptive statistics is the study of how data can be summarized effectively to describe the important aspects of large data sets. Now, as investors, we are concerned about the return on our investments. So most of our examples are going to be about returns. Now, let's say you have the data on a company's returns for the past 50 years, right? Now, if I have that data set, I can get a lot of information. I can have a lot of descriptive information about that data. I can talk about the central tendency of the data, meaning where those returns are centered. And we use different types of averages and means to do that. And yes, we have more than one type of average. I can also talk about the dispersion of the data, meaning how dispersed or how far away are those returns from their center. And we use central tendency for the to find out about the potential reward of the investment, and dispersion to find the potential risk. We can also talk about the skewness of the data, meaning the shape of the distribution. Is it symmetrical or not? I can also talk about the kurtosis, uh, whether the extreme outcomes are likely or not. And we will talk about each of them in detail later on. But when it comes to descriptive, the point here is that we are not trying to make any estimates or forecasts. We're not trying to make any judgments about the data. If we are given a data set, all we are trying to do is that we're just trying to say that this is what I see in the data. That's it. Inferential statistics, on the other hand, involves making forecasts, estimates, or judgments about a larger group from the smaller group. And here, when we say a larger group, normally we mean a population. When we say the smaller group, we're talking about a sample. And the reason we take a sample is that sometimes it might be not possible or costly or time consuming to do whatever analysis you want to do on the whole population. So you take a sample and you do the analysis on that instead of the population. So if you can think of this whole circle, the bigger circle as a population, the smaller one would be a sample taken from the population. But to do the inferential statistics, the foundation of inferential statistics is probability theory. So you got to get through that one first. Then we can talk about inferential, which we will do later. But now our focus is going to be descriptive. So I mentioned the term population and sample, and there's a critical distinction between these two. So let's define them. A population is defined as the set of all possible members of a stated group. A sample is a subset of a population. So you can think of, let's say, all the stocks traded on the New York Stock Exchange as our population. And if we take 30 of those stocks, we can make a sample. Another example would be, let's say you want to do some research about the mobile subscribers in the whole world. That could be your whole population. But again, it would be impossible or very costly to do the analysis and gather all those data. So you take a sample, and let's say you take your sample, all the mobile subscribers in your country. You take that as a sample. Now, when we are talking about a population, again, I don't want to get into the whole sampling and estimating topic, because we will see it later on. It's a whole topic on its own. But when we're talking, if we have the option of doing the analysis on the population, obviously that would be the best option. But the reason we go for the sample is that this is not possible, so we take the sample. And when we are taking the sample, it is critical that that sample be truly unbiased and be representative of the population. Otherwise, what's the point of doing the analysis on the sample? Because you wanted to take that instead of the population. So if it's not a good representative, there is no point doing that. Now, we have also different notations to show whether we're talking about a population or a sample. Let's say we're talking about the average of a population. If we are talking about the average, we show it with a notation called mu. And if we are talking about the average of a sample, we use the notation called x bar. And again, because for the reader, if they understand that you have taken and you showed this notation, and they know that whatever result that you have is quite accurate because you have used all the members of that population. And if you see this one, you got to stop and ask, how was that sample collected? Is it truly representative of the population or not? Now, whatever descriptive measure that we have on a population, it's called a parameter. And if it's on a sample, it's called a sample statistics. So this one would be a parameter, this one would be a sample statistics.